there's a spoofed standard which talks about, pigeon carrier-based transport of data. It's, some of the funny geek things you get into as you start looking at all these different standards. Maybe I'm just too geeky for that kind of thing. All right, so we take this information, we've got our binary at the physical layer, take our ones and zeros, and now we convert it into a data link frame. We now have the layer 2 and layer 2 header and the layer 2 trailer, and we start stripping this information off as we head up the stack. Now, there's another point that you should understand as far as inner layer communication, and there's something called a SAP. It's a source access port, I believe is the correct term there. And really what it is how we communicate between layers. In particular, the layer 2 header is going to have an identifier in it that tells it what layer 3 protocol this layer 2 header has inside of it. So, for instance, to give you an example here, layer 2, if the SAP identifier says it's 0x800, so hexadecimal 800, that means it's an IP packet. So when we strip off the layer 2 header, we know to hand this packet off to the processor for handling IP packets, as opposed to, say, handling IPX packets or some other possible layer 3 protocol. So the network layer gets a hold of it and looks inside the layer 3 header. And another thing that's important here as we're de-encapsulating this data is that we only de-encapsulate data when the destination is for our machine. So when a machine gets a hold of this, a host has it, it looks inside of, back to layer 2 header, looks inside the layer 2 header, and if the destination isn't destined for the machine, it's not going to open it up. It simply discards the layer 2 header as a message for somebody else, and we throw it away, and we don't need it. And this happens quite frequently in certain technologies, like, say, Ethernet. Ethernet, you'll get frames all day long that are destined for other machines, and you simply discard it and go on with life. But if the message is destined for you, or it's maybe a broadcast or multicast address that you're going to listen to, then you'll open it up. So you open it up, you hand it up to layer 3, it looks at it and says, is this destination IP address for me? Again, it could be a broadcast or a multicast, but also could be a unicast, meaning directly destined for that machine. If it is, then we're going to hand it up to layer 4. We strip off the layer 3 header. We look at the SAP information inside a layer 3 header. In the case of IP, it's referred to as the protocol field. The protocol field, which would identify whether it's a TCP or UDP layer 4 or possibly some other layer 4 type transport. So we strip that off. We know to hand it over to UDP or TCP at layer 4. We go up to layer 4 header. We look inside of that, and then we look at the port numbers. And we say, do I have this particular application open? And as we take a look at, going back to my original example, this is de-encapsulating on the side of, say, Google. So Google's opening this up, and really what we're looking for is the destination port 80, because I've got a web server that's listening to port 80. And if it is, great, I can strip that off and start moving up the application stack portion of it, which is the combination of the session, presentation, application layers. Those upper 3 layers are often referred to as the application layers when you look and compare it directly to the TCP/IP protocol stack. So as we communicate up the rest of this, we identify, the layer 5, 6, and 7 portions of that information to finally get the request to the server, which was a GET request saying, hey, I want the Google homepage. At which point we repeat the encapsulation process. We take the data, which would be the Google homepage, and we go back down the stack to communicate back to the original host, creating the layer 7, 6, 5, 4, 3, 2 headers, encoding it in binary and sending it back to the host.